Well, it's good to be with you again today. We are starting into our last section of this chapter. So let's see what you need today, what's coming ahead. For your materials, just one activity, activity 2-3, and that is the tiny table sheet that we've been working on, and you're going to finish filling that out today during the lesson. On the agenda, we're going to start by reviewing. We're going to go over the chart that you should have done for your section review, and then we're also going to do a little rock review, something that you've probably learned before, and we'll be talking about forces that change the Earth's surface. That's our main topic for today, and we'll also have a little rock hunting fun during the lesson. Our main idea today is that the Earth's surface is changed through heat and pressure from volcanoes, water, and wind. And the goals for you today are to define and contrast the two types of tectonic activity, which are faulting and folding, and also to define and contrast the two external forces that shape the Earth's surface, and those are weathering and erosion. So if you've had Earth science, some of this will be reviewed for you today. So hopefully it won't be too difficult. Something just a little refresher from what you've learned previously. Let's start out with our chapter verse today. Go ahead and read this with me. 2 Peter 3, verses 5 through 7, chapter verses. For this they willingly are ignorant of, that by the word of God the heavens were of old, and the earth standing out of the water and in the water, whereby the world that then was, being overflowed with water, perished. But the heavens and the earth, which are now, by the same word are kept in store, reserved unto fire, against the day of judgment and perdition of ungodly men. All right, so I hope you've been working on that outside of class, because that's a little more difficult than our first chapter verse was. A few more verses there. Now we're going to start with our review, and I'm not going to go over all the section review questions with you. Hopefully Mom and Dad already checked over that for you and let you know how you did on that. But you were to make a chart of the Earth's water features. So that's what I want to take a look at. And on your chart, I didn't set mine up real nicely here, but this just gives you an idea of what your chart would look like. The ocean, the rivers, the seas, the gulfs and bays, and then I just listed for each ocean what went with it. But what I want to look at with you is actually the map and show you where these things are on the map, and these are the features that you should have in your chart, and that way you can see if you left anything out. So let's start with the Atlantic Ocean, and we want to find out what rivers flow into the Atlantic Ocean. Now this map looks pretty tiny for you, so you want to be sure to turn to it in your textbook. It's on pages 1 and 2, right at the beginning of the book, so you can follow along on your map at home, and I'll point to the general area where you need to be looking. Okay? So I just started in North America, and this is nice because they don't have everything labeled, so all you have to do is use the features that are labeled on this map. In North America, the Mississippi River flows into the Atlantic Ocean, well, the Gulf, and then from there into the Atlantic Ocean. We have the Amazon River in South America that's also flowing into the Atlantic. The Niger River from Africa flows into the Atlantic, this direction, into the Atlantic. The Nile eventually does come out to the Atlantic. It's flowing into the Mediterranean Sea, which is attached to the Atlantic. That one might have been a little more difficult. The Congo, right here, also in Africa, flowing into the Atlantic. And the Danube, that's one that wasn't listed. If Mom and Dad used the teacher's edition to check your work, I'm not sure. They had a little special note by that, so I'm not sure how that was listed in the teacher edition. But it does flow here and then eventually into the Atlantic Ocean as well. Okay? Then we want to move on to the Gulf Seas and bays that are part of the Atlantic Ocean. For the seas, we have the Labrador Sea right here off the coast of North America, the Caribbean Sea between North and South America, the Mediterranean Sea, the North Sea right here off the coast of England, the Baltic Sea, which is right here near Scandinavia, and the Black Sea, which is right here in Europe. And then we have the Weddell Sea, and this is one that you probably did not get. I'll kind of show you. you can see I've got my pages cut apart. The Weddell Sea is right here in the seam. So in your book, you probably couldn't even see that. It's kind of sewn into the seam. So if you miss that one, just go ahead and jot it down. It's W-E-D-D-E-L-L. 2 L's on the end there, the Weddell Sea. All right, and then our Gulfs, we have the Gulf of Mexico. That's pretty simple. And then we also have the Gulf of Guinea. That is off the coast of Africa. And for our bays, we have just one, the Hudson Bay. Oops, the Hudson Bay. That one's pretty hard to miss. Okay? All right, so that takes care of the Atlantic. Then we move on to the Pacific. This is the one that had the most features flowing into it. It is the largest ocean, and so this will take a little bit more time. But the Pacific. For our rivers, we have the Yukon River from Alaska flowing into the Pacific, and then we have the rest of ours are from Asia. The Amur River is up here in Russia, flowing out by Japan's northernmost island. Then we have the Yellow River, China, the Yangtze River also from China, and the Mekong River also, it's flowing through Indochina here on this peninsula. Okay, then for our seas, this is where there's a pretty good size list. We have the Bering Sea over here by Alaska, okay, between Alaska and Russia, the Bering Sea. Then we have the Sea of, I've had to practice this one a little bit, Okhotsk, which is right up here by Russia, the Sea of Japan between Japan and Asia, the East China Sea, going down a little bit further, the Philippine Sea by the Philippine Islands, the South China Sea. Then down here by Australia we have the Coral Sea, the Tasman Sea, and then right down here on the bottom, did you catch this one? The Ross Sea. The Ross Sea, that was kind of a tricky one there. And there are no gulfs and bays listed on this map that go along with our Pacific Ocean. Okay, now to the Indian Ocean here. For our rivers, we have the Indus River and the Ganges River here in India, and then Africa does have the Zambezi River pouring out into the Indian Ocean. And then we do have the Arabian Sea and the Red Sea for our seas, and for gulfs and bays, we have the Persian Gulf here and the Bay of Bengal. All right, then we have our Arctic Ocean to finish up with. Okay, so we want to see what rivers, seas, and bays go along with our Arctic Ocean. So first of all, the rivers, we have the Mackenzie River here in North America, empties into the Arctic Ocean. Then in Asia, we have the Ob River, the Yenisei River, and the Lena River. Those are all emptying into the Arctic Ocean as well. We have a few seas. The Beaufort Sea here above North America is part of the Arctic Ocean. Then we have the Greenland Sea off the coast of Greenland, the Barents Sea here above Scandinavia, the Kara Sea above Russia, and the Laptev Sea above Russia. And we also have one bay that goes along with the Arctic Ocean, the Baffin Bay, which is here between Greenland and North America. And that concludes our review. Now we're going to go ahead and move into our section about the forces that are acting upon the Earth's surface. And in your textbook you have a verse, Job 28, 9 through 10. He putteth forth his hand upon the rock. He overturneth the mountains by their roots. He cutteth out rivers among the rocks, and his eye seeth every precious thing. All right, so we're talking about the Lord and the rocks, God's control over the earth. And so before we get into our section, we are going to do a brief review of the basic rocks that these forces are acting upon. Do you remember the 3 basic types of rocks probably from your science class? Well, our rock types include sedimentary, and they're actually labeled according to how they were formed. So sedimentary rocks were formed by the hardening of sediments, and that's where they get the term. And sedimentary actually means settled out of solution, and therefore the likelihood that much of the Earth's sedimentary rock originated at the time of the flood is great. And what happened is, as the flood's water subsided, material settled out of the solution in layers, resulting in layers of sedimentary rock where the materials were allowed to harden. Another rock type is the metamorphic rock, and it is formed by a change in structure under pressure, like heat or some other force. And A chemical reaction would be another force that could cause a rock to change and go through that metamorphosis. And creationists believe that the heat and pressure caused by the flood, right, changed volcanic and igneous rock into metamorphic rock. And of course, igneous then is our last type of rock. And igneous rocks are formed by volcanic activity, and igneous rocks are actually the only type of rocks that we can watch being formed today. And now that we've reviewed our different types of rocks, let's go on a rock hunt and see if we can find some samples.
They can spot them from miles away. They travel the globe to find them. The passion of these valiant hunters continually leads them onward to new heights and greater challenges to find their prey. Rock. Yes, these are the hunters of the rock. Let's observe the collecting methods of these industrious adventurers. All good rock hunters are aware of the three types of rock: sedimentary, igneous, and metamorphic. Hunters perhaps of the more organized sort, such as this, are content with photographing specimens and recording notes. Other fearless collectors use the tactile approach of rock gathering. That is, they must touch, lift, and possess the rock. Oblivious to the world around them, those with the rock passion only have eyes for one thing. Even amateurs know that igneous rock is the only type of rock we can watch being formed today. It is formed from volcanic activity, when magma flows onto the Earth's surface or when it boils slowly below the Earth. Sedimentary rocks are formed by the hardening of sediments. And metamorphic rocks are formed by, well, by metamorphosis. At least when it comes to large rocks, the one method of rock collection is definitely preferred above the other. Creationists believe that sedimentary rock was laid during the flood, and that heat and pressure caused by the flood changed volcanic and igneous rock into metamorphic rock. We also note that when it comes to carrying around what you've collected, one method is definitely superior to the other. Thanks to these heroic hunters, the pursuit of rock specimens continues, regardless the manner of collection utilized.
All right, well, if you want to do your own rock collecting, you should have learned a few pointers from that right there. Now, we're going to get into our forces that change the Earth's surface, and the two processes that change the Earth's surface are the internal and external processes. For the internal processes, we're looking at tectonic activity, volcanic activity, and then for the external processes, weathering and erosion. So those should ring a little bell. Maybe you've studied them before in earth science, or at least from our main concept and our goals for today. That should sound familiar. With our internal forces, before we get into the tectonic activity, we need to understand the plate theory. And the plate tectonics theory is a theory, so keep that in mind. It's the idea or theory that the Earth's crust is broken into several plates which crash into one another and pull apart. And it includes the idea that movement of the plates releases energy, causing earthquakes and volcanoes. Also, the clustering of those volcanoes and earthquakes on distinct lines of the Earth's surface supports the plate tectonics theory. And this is one of the main evidences for this theory. And there's a map in your textbook on page 33 that lays this out for us. And on this map, we have the different plates. Let me show you the key here. The earthquakes and the volcanoes, the plate edges, rifts, and direction of plate movement are all marked. But just for an example, let's look at the North American plate. Here we see the edge of the plate, and you can see all of the black dots clustered around it. Same along here, black dots clustered along the edges, another cluster, and it's very clear that these earthquakes and volcanoes are clustered along the edges. And if you want to look further at that map, there are some questions there at the bottom, just some ideas to think about in relation to the plate tectonics theory. And some creationists believe that the Earth's crust was broken into plates during the flood. Remember we talked about the fountains of the deep being broken up? But other creationists reject the plate tectonics theory because it's generally used by evolutionists as an alternative to the flood. For example, they're trying to explain worldwide distribution of fossils. Well, it wasn't due to a worldwide flood. It's due to the fact that the plates are all together and now they've broken apart. And so some people reject the theory due to that. Now that brings us to our tectonic activity, and by this we simply mean movement of the Earth's surface. So it's just kind of a fancy term for a simple idea. And our evidences of tectonic activity include faulting and folding. Faults are deep cracks in the Earth's surface, and folds are actually bends in the Earth's surface. And again, your textbook illustrates this. This is on page 31, and here's an illustration of a fault. This is actually a thrust fault, which occurs when one side of the fault moves up, as you can see here, while the other side of the fault shifts down, and you can see the downward arrow there. And another common type of fault is a strike-slip fault, and that's when the two sides are moving horizontally in opposite directions, kind of like this. So the two sides slip by each other without a vertical rise. And the San Andreas Fault in California is a classic example of this type of fault. Then also in your textbook, we have a photo, which is an example of a fault. You can see right here where there's just a big crack in the Earth's surface. All right. Now, above that, we have a picture of a fold, which is just a bend in the surface of the Earth. And back to page 31, you can see the diagram of the fold and what's happening there with the surface of the Earth. How do you think faulting and folding has affected the surface of the Earth? We're talking about forces working on the Earth's surface. Well, it appears that some mountains have been formed by faulting and folding, and these are referred to as deformational mountains. Just think of the word deformed, and deformational follows that. What type of fault do you think would form a mountain? We talked about our strike-slip fault and our thrust fault. It's probably the thrust fault, right, where one side is going up and the other side is going down. But no one has actually ever seen this taking place. It's just an idea. The folds and faults might have formed during the flood, when everything was, the fountains of the deep were breaking up, or God may have just created the Earth with them. So they could have been there from the very beginning. Now our other internal force is volcanic force, and people have been able to observe mountains being formed by volcanoes. The volcanoes actually deposit lava which builds up into mountains, and these mountains are referred to as depositional mountains. So think of deposit, the volcano deposits lava, and you have your depositional mountains. And you read about some specific examples of deformational and depositional mountains in your textbook. Now, in addition to our plate tectonics theory, some scientists have come up with the continental drift theory. And this is the idea, again, they're both theories, ideas, that the continents used to be connected in one large landmass, but they broke apart and, over millions of years, drifted into their current positions. And of course, we do have a problem with this theory. These scientists were not there to observe the events that we've talked about, so the idea is merely a theory, and they must use faith to believe in their theory, just as Christians must use faith to believe that God created the earth, and it didn't form over these millions of years, and these things didn't take place over that time period. However, Christians also have a record of creation in the Scripture, so we even have further evidence than what the scientists are looking at. Now, that brings us to our external forces that are working on the Earth's surface. Do you remember what they are? We have weathering and erosion. Now, by weathering, we are simply referring to the breakdown of rocks, and it is caused by temperature changes, water, plant roots, and the formation of ice and mineral crystals. And you can probably imagine how each of those takes place. If there's water that has seeped into a rock and it freezes and expands, or something like that, breaking the rock apart. The plant roots, you've probably seen that in sidewalks where somebody has a nice smooth sidewalk and a plant starts rooting its way up and makes a big crack there. So those are the types of things that break the rocks down, and there are particles formed by this, like sand, silt, clay, and these mix with humus, which is actually decayed matter, and the result is soil. Soil is produced, and we see some unusual rock formations due to this weathering. And our second force, external forces working on the surface of the earth, is erosion, something again that you're probably very familiar with. But erosion is actually the natural removal of those particles, those weathered particles. So they go hand in hand. And erosion is caused by wind, and you can think of water. Water in the form of waves, glaciers, which are large masses of moving ice and snow. You've probably already learned that before, and running water. So you can see 3 of our 4 forces causing erosion are forms of water. The waves are the lapping water, the glaciers are frozen water, and then the running water that also helps erode the earth. And the Scripture even talks about erosion. In Job 14:19 we read, "The waters wear the stones. Thou washest away the things which grow out of the dust of the earth." And here we can see some of the effects of erosion. The waves lapping along here. It's pretty calm right here, but you can see where it's worn away the bottom portion. And as we go up further, we can see some evidences of wind erosion. Here we can see the water lapping. You can see how the erosion has smoothed off these rocks. And again, some pebbles, and there you see the water, the waves lapping over them. Here we'll see some evidence of erosion from running water. And glaciers are also a force that acts on the Earth's surface. And here in a moment you'll see the path that this glacier has taken down the mountain. So you've been able to observe some of the effects of erosion. Some other results of erosion are sand dunes, terminal moraines. Those are actually hills of debris left behind glaciers, sea caves and arches, and sandbars, barrier islands, and also gullies are results of erosion. Another type of force that works on the Earth's surface, in addition to weathering and erosion, is mass wasting. And this is just a third process that affects landforms. Mass wasting is the pull of gravity that changes a landform. For example, an overhanging cliff that's weakened by weathering processes may eventually fall to the ground below, creating a pile of debris that is a new landform. A steep slope also sometimes has a downward creep of soil and debris and things like that. That's also considered mass wasting. And right now we're going to look quickly at the section review together. Since we're wrapping up, I want you to have time to work on your chapter review. In your textbook on page 35, what evidence supports the plate tectonics theory? The main evidence is the clustering of earthquakes and volcanoes along distinct lines. The second question, I'm kind of rushing a little bit just to make sure we get done. The two most notable types of tectonic activity, do you recall? Those would be faulting and folding that we can observe. And then we're asked the difference between weathering and erosion. They're related but not the same. Okay, weathering, recall, is the breakdown of rocks. We talked about the different processes, just briefly what different types of things, plants growing, that type of thing. Erosion is the actual removal of that rock material by the wind, the waves, the running water, and the glaciers. Okay? For forces that cause erosion, well, I just listed those for you. Number 5, what does weathering help to produce that is essential for life on the earth? I don't think I mentioned this specifically, but if you think about the rocks are broken down and the material is swept away, it creates sediment or soil, and that's of course necessary for plants to grow in. And then our thought question. The text mentions two types of mountains, which we covered in our lesson: deformational from earthquakes and depositional from volcanoes. There is a third type called erosional, called an erosional mountain. Based on what you have read, how was this type of mountain formed? Well, you haven't read it yet, but you can guess just based on what you learned about today. If a deformational is formed by your faulting or folding, a deformation in the surface. Depositional is formed by deposits of lava. Erosional then would be formed by erosion, right? They're carved out by extensive erosion of loose rocks, and it leaves behind the hard materials. And it's noteworthy that many erosional mountains come in the shape of mesas and buttes. And that's if a plateau is eroded, or as isolated mountains called monadnocks if a whole region is eroded. And Stone Mountain is an example of a monadnock. Perhaps you've seen that before or visited there before. That's going to wrap up our section, so let's go ahead and take a look at your assignment today. Now, I did quickly go over the section review with you, but you do need to read through the section, pages 31 to 35, and complete the chapter review on page 36, because of course, next time we'll do just a little bit of review and then we'll be having our test. So you want to make sure to have plenty of time to get that done this evening or whenever it is you'll be tackling your assignment. Now, as you read, think about this question. Does the World Relief Map show the places that are most prone to catastrophes such as earthquakes, volcanoes, and flooding? Okay, so keep that in mind. Could you see those areas on our World Relief Map at the front of our book? And last time we had our Where in the World question, so let's look quickly and see what the answer to that is. Where do only 2 flowering plants grow? And that is in Antarctica. One of those plants is a relative of a carnation, and the other one is a flowering grass. And for our new question, see if you can discover where is the city of Cologne, which is famous for its scent.